Hello, thank you for watching this video. So in this video I'll be doing question 6 of November 2020 question paper, mathematics paper 2. So I'll read the question 6 statement and then proceed to answer the questions that follow. Okay, so in the diagram, P and T lies on the positive x-axis and the angle O of POT is equal to theta. I'll read the statement again. In the diagram, P and T lies on the positive x-axis and the angle O of POT is equal to theta. So in this diagram here, so we have our POT, the points P, O and T, and the angle O of POT is equal to theta here, right? So we have a P, you have a O, you have a T. So let's continue. Answer the following questions without using a calculator. So they are saying we should answer the following questions without using a calculator. 6.1.1. Write down the value of tan theta. So they want you to find the value of tan theta. What is your tan theta? So the first thing you do, you ask yourself, how do you express tan as a trig ratio? So tan is the opposite side over the divided by the adjacent side. So you go to your drawing. So here's our drawing here. I think I'll get the orange color. So we have theta here. So now we must complete this diagram. So if you look at this diagram, we have -5 and 12. So this is your x coordinate and this is your y coordinate, right? So if you drag it down here, form this right angle triangle. So this height here is your y. This is your y value, which is that there, right? So there, this height here is your y value, the vertical height. So you can read it there, and this here is your x value. So you know that x here is -5 at this point, and there your x is 12. So now you want to find tan theta. Your tan theta is equal to the opposite side divided by the adjacent side. So the opposite side of the opposite side to this angle is this one, which is is your height, and the adjacent side is this length here, which is your -5. I repeat, to this angle theta here, the opposite side is this height here, and the adjacent side is -5. So you know that you have expressed your tan theta here as a trig ratio that is opposite of over adjacent side. So the opposite side to this angle is 12. Is 12 divided by the adjacent side. The adjacent side is -5. This is how you do the first one. Then you're done. Go to the next question. Calculate the value of cos theta. So they want now the value of cos theta. So how do you express cos theta as a trig ratio? So your cos theta is equal to the adjacent side over the hypotenuse side. So we go to theta again. Here with theta, what is our adjacent side? Our adjacent side is this 5 here, like up there. Our hypotenuse, which is the longest side of our triangle, is this one here. So this is your adjacent side to your theta. This is the opposite side. This is your hypotenuse. But we don't have the value of the hypotenuse. So which means now we need to find what this value is. Since we have the right angle triangle, we'll use Pythagoras theorem. So we say, okay, r squared is equal to x squared plus y squared. Your r squared is what you're looking for, which is your PO, which is your PO squared is equal to x squared, which is this, minus 5 all squared, plus your y squared, which is that, 12 squared. So this is 25 plus 144, right? So your PO squared is equal to this. Your PO squared is equal to 169. And you take the square root, your PO is equal to 13. So the longest side of our triangle, which is our PO, is equal to 13 units. So we have decided that it is 13 here. Then we go back to our trig ratio. So we said cos theta is equal to the adjacent side over the hypotenuse side. So what is the adjacent side? Our adjacent side is this one here. It's minus 5. The hypotenuse, which is the longest side of the triangle, divided by the hypotenuse. The hypotenuse is 13. We're done with this one. Go to the next question. So S is a point in the third quadrant such that TOS is equal to, such that the angle O of TOS is equal to 90 plus theta, and OS is 6.5 units. Calculate the value of B. I'll read this question again. So S is a point in the third quadrant such that the angle O of TOS is equal to 90 plus theta, and OS is equal to 6.5 units. Calculate the value of B. So you're told that you have a point here on the third quadrant, right? So the point S somewhere here on the third quadrant. What the information that you are given, you are told that this point S is 90 degrees away from this one here, from P, because they're telling you the angle TOS is equal to theta plus 90 degrees. So which means you know your theta was starting here and ending here, right? So now your point S now, if you're going to expand this angle of O of the origin, or angle by the origin by 90 degrees, which means now you must be 90 degrees away from where your theta ended. So what that means is this point that we have is 90 degrees away from, your theta. So here is it, here is it. So this is your point S here with A and B, right? Like we did here. We say, okay, this is your X coordinate and this is your Y coordinate. Therefore, okay, I'll extend this a bit. Let's say S is somewhere here. So S is this point here, not this one anymore. So now, let's connect this on the x-axis. So it's not at 5. 5 is here, so this is another value. So because we're not told what is the value of A. We don't know what the value of A is. We don't know what the value of B is. So we don't know if this triangle or this OS is shorter or longer. Or if your value of X here is smaller or bigger than 5. No one told you that. So you don't know that. So given the information that you know, you can just say, I know that it will you can complete a right angle triangle here. So we have our right angle triangle here. Okay, so now let's continue. Calculate the value of B. So they want you to calculate the value of B. What is B? B is your Y value here. Because this is your X, and so B is this value here. And A is the value here, your A. Your X, so X value, your B, your Y value, which is that. So, they want you to find the value of B. So how do you relate B and this angle here, which is what? Which is 90 plus theta. So you can relate B that you want and this angle here by the trig ratio of sine. So you can say, okay, sine, so this is 6.1.3. 6.1.3 sine theta plus 90 is equal to your opposite. What is your opposite side of this angle? Here, this angle here. The opposite side is B, which is your vertical height here, over hypotenuse, which is OS. But you're told that your OS, okay, B over, your opposite side, B over OS. OS is 6.5. Right? Then you simplify this. You say, okay, sine 90 plus theta is equal to B over 6.5. So, when you have a situation like this here, you say, okay, you ask yourself, you need something like this. Something like this. So 0, 90, 180, 270, and 360. So here you have your theta greater than 0, right? So you have your 90 minus theta here. You have your 90 plus theta here, which is your angles that are here are less or equal to 90, this quadrant. Here they are greater or equal to 90. Here they are less or equal to 180. They are greater or equal to, 180. They are less or equal to 270. You can see 360 minus theta, right? So you know here your sine theta is greater than 0. Your cos theta is positive, and your tan theta is also positive. So here your sine theta is positive, your cos theta is negative, your tan theta is negative. Here you say, okay, my sine theta is negative, my cos theta is negative, my tan theta is positive, right? So here you say, okay, my sine theta is negative, cos theta positive. My cos theta here is positive. The tan theta is negative. So this is what you use. This is what you use to simplify this. And then you ask yourself some questions. Which quadrant is 90 plus theta? The question you ask yourself. 90 plus theta is on the second quadrant. What sign is this function there? So sine on the second quadrant is positive. So your simplified version of this is sine. Oh, sorry. Okay. So you ask yourself some questions, right? Which quadrant is 90 plus theta? 90 plus theta is on the second quadrant. What sign is your function there? Your function there is positive, right? And then now, if here on your maximum you have 90 or 270, right? If your maximum here is 90 or 270. Then your function changes to its core function identity. I'll repeat. If your maximum here is 90 or 270 or is along the verticals, then your function changes to a core function identity. So, since you have sine here, your sine will switch to its core function identity, which is cos. So we have cos theta is equal to b over 6.5, right? But you found the value of cos theta there to be minus 5 over 13 is equal to b over 6.5. Then you cross multiply here, say b is equal to minus 5 over 13 times 6.5. Hash this in your calculator. I will do that right now. Minus 5 over 13 times 6.5. And your b, your value of b is equal to minus 5 over 2. So your b here is equal to minus 5 over 2. Which means now, your b is not here, it's below, so it should be here, somewhere here. Which is our correct value of triangle should be somewhere in the middle here. It's minus 2 over 5, which is minus 2,5, which is somewhere here. So, which means our triangle is something like this. Not as big as we made it, but it doesn't matter. We didn't have that information when we drew it. So we worked with what we have and we discovered this. Then we go to the next question. 6.2. I'm going to clean the board now. Okay, so now 6.2. Determine, without using a calculator, the value of the following trigonometric expression. So they want us to find the value of this, right? Okay. So what we do here, we say, okay, we want to simplify this. So you want to make sure that you only have your sine x, maybe cos x. You don't want these negative. You don't want these numbers there. So that's the first thing that you want to remove. If this was positive, you would be happy with it. Alright? If it was positive, cos x, it was fine, we're going to be fine. Cos 2x is okay. This is not okay. You want to simplify that. You want to simplify this, and you want to simplify this as well. So the things that we are unhappy with here, you want to simplify this to just x. X is only just x. Not negative x, not x plus something. Okay, so what we assume that your x is positive, like we did there, but you said theta there. You assume that your x is positive. So this is negative, right? This angle here. So now, when you have a positive angle, so when you have a negative angle, add 360 to it so that it becomes positive. Because you want to work with the simplest forms of angle, which is the positive ones. So those are the ones that you would want to be accustomed to or used to, because the positive angles are not difficult to deal with. So now, the first thing that we're going to do here, we're going to add the 360 here. So in any of these, if you see a negative angle, add 360 to it so that it becomes positive. Once it becomes positive, you will see easily where it fits here. So let's do that. So we're going to say, okay, sine 2x times cos negative x plus 360, right? Plus cos 2x times sine 360 minus x, all divided by sine 180 plus x. So one would argue that I could have simplified this and that one, which is true. But I would like to simplify them all in the same step. I would not want to simplify them separately. So I want to simplify them in the same step, so that what I'm doing is consistent. I don't want to start simplifying because it's easy to make mistakes when you do that. So you want to simplify all of your expressions at the same point. So let's go. So you say, okay, sine 2x times. Where is negative x plus 360? Which is, this is same as 360 minus x. So which quadrant is 360 minus x? 360 minus x is on the fourth quadrant, right? What sign is cos there? Your sign is positive. So your sign is positive, put it in a bracket like that. And then now you have cos x now, which is what we like. We want a positive angle. So this sign is not an addition of the two. You're not adding these two, but it's a sign for cos. Then you say plus cos 2x times. Where is 360 minus x? 360 minus x is also on the fourth quadrant, right? What sign is this sign function there? This sign function is negative there, because here is it. We said the sign is negative there, so negative sign. So we have negative sign x here, all divided by. Ask the same question. Where is 180 plus x? 180 plus is on the third quadrant. What sign is this function there? This sign is negative there, right? So which means now what you're left with is sine x, which is negative sine x, because your sign is negative there. And then now we want to simplify. We say, okay, this positive, this times this positive, sine 2x times cos x. Negative this times that, so it's negative cos 2x sine x, all divided by negative sine x. So this is what you have. So when you are here, one would argue and say, okay, this looks like a compound angle, right? So this looks like a compound angle. So a compound angle is something like sine A plus minus B is equal to sine A times cos B minus cos A times sine A. So one would say this is that, which is true. Which means now you can write the top here in this form. So which means the top here, so this is your A and this is your B. And you keep the sign minus as we did there. So you have sine 2x minus x over negative sine x. Which means you have sine x over minus sine x. Therefore, this is equal to minus 1. So which means the simplification of that, the value of that is minus 1. Provided that this thing here is not equal to 0. So this is how you do this. So you need your knowledge of your compound angles, and yeah. So we're going to do question 6.2. Determine the general solution of the following equation. They want us to find the general solution of this equation. That's what they want us to do. They want us to find the general solution of this equation. So they want us to solve this equation, right? So your equation is 6 sine squared x plus 7 cos x minus 3 is equal to 0. So now, the easiest way to solve this kind of equation, so look at what you have here. We have sine squared x and you have cos squared x. So we have two different functions here. So what you want to do is to make them, change them and make them the same. You can make both of them sine x, or you can make both of them cos x, whichever is easier to do. So you can either make both of them sine x or both of them cos x. That is what you need to do. So the easiest one to do, I would say, is to make both of them cos function. So we have this identity here that we know very well, that sine squared x plus cos squared x is equal to 1, right? So 1 sine squared x, you transpose this to the side, so we're left with sine squared x is equal to 1 minus cos squared x. So, which means now when you see your sine squared, you will put 1 minus cos squared x. So where there is our sine squared, so we have 6 into 1 minus cos squared x plus 7 cos x minus 3 is equal to 0. Right? Then you multiply this out, you're simplifying it. Because now, at least now you have the similar function, same function, which is cos. That's what you want. You don't want many functions there because you won't know how to deal with them. But if you have one way, it may be easier to work with them. If you have one function. So now to simplify, this times this, 6, multiplying here, multiplying there, minus 6 cos squared x plus 7 cos x minus 3 is equal to 0. So we simplify, we have minus 6 cos squared x plus 7 cos x minus 3 plus 6 is equal to 0. So what do we have? Minus 6 squared x plus 7 cos x plus 3 is equal to 0. That's what you have. So now, when you are here, I'm not sure if you can see this. So this is minus 6 cos x squared plus 7 cos x plus 3, which is equal to 0. If you think about it, this is similar to question 1 of maths paper 1, solving x. Because if you look at this as your x and that is your x, you will realize very quickly that you have a quadratic equation. So if you can look at this instead of x here, so this is 6 minus 6x all squared and plus 7 cos x plus 3 is equal to 0. You will see this resembles the quadratic equation, which are on question 1, mathematics paper 1. So this is very similar to that. But when you have your x's and whatever, you will be solving your x. But now you have cos x, so now you're solving for cos x. That's what you're solving for. You're solving your cos x. So you must factorize when you get here. But I will not do that because some people don't know how to factorize. So let's use quadratic equation. So 1 cos x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So this is what we're looking for, because when you have x here and x here, you have x squared and your x, and then you say you solve for your x, right? So you're solving for cos x here. So cos x is equal to negative b. What is your negative b? What is your b? Your b is 7. This guy here. Plus or minus square root b squared. What's your b? 7. All squared minus 4a. Your a is minus 6. And your c is 3. All over 2a. What's your a? Your a is minus 6. So your cos x is equal to or your cos x is equal to. So you punch this in your calculator, see what the value of cos x will find. So I'm punching on mine. Cos x equal to minus 1 over 3. The other one is 3 over 2. Right? So this is a function of, so this is cos x and that is cos x. So you know very well that, look at this 0, this is your y, this is your x. You know very well that, so let's say this is your 0. I want to plot cos x. 1 minus 1, 0, minus 1, 1, 1. So 0, 90, 180, 270, and 360 here. So this is your cos x. So the highest value there is 1, and the lowest value here is minus 1. Right? So the function cos x is a periodic function. So it's a repetition of this thing. So if you can go for another 360 units, it will do the same thing. So if you can extend this direction for 360 units, it will have the same shape. So this function is just keep on repeating. So it's called a periodic function. So after every given period, fixed period, it repeats itself. So this is always between, so your cos x is always between 1 and minus 1. So your function will always be between minus 1 and minus 1. It's never above 1, it's never below minus 1. If it's this one here, it's always between 1 and minus 1. It will keep on repeating the same shape. So now, this is saying cos x equal to 3 over 2. This is not possible because you see that your graph is always, your function cos x is always between 1 and minus 1. So this does not make sense. You can cancel this thing out. Just leave it, this one. This one, cos x is equal to negative 1 over 3, which is negative 0.33. Negative 0.33 is somewhere here or somewhere here. So we can continue with that solution, but not this one, because this one, there's no way possible your cos x is above 1, because this is 1,5. It is always between 1 and minus 1. So we continue with that one. So what we need to do now is to find the reference angle, right? We need to find the reference angle. So we say, to find our reference angle, we say, okay, we say reference angle, right, is equal to arc cos 1 over 3, right? That's what you say. You say arc cos 1 over 3. You don't put in the sign. You don't put your sign in here. So you use the sign to find the actual solutions of x. So now your arc cos this is equal to, so to press this you say shift cos 1 over 3. So you have 70.53 here. So your reference angle is 70.53. Okay, so what do we do now? We say, okay, we have our reference angle. So we want to find the solution of cos x, of x, right? Where our cos is negative. So this angle is showing us the quadrant in which we're going to find these solutions. So I'm going to draw The same thing that I drew in the previous question, but I cleaned it. I didn't know that I was going to need it again. So we say, okay, this is what we have. This is 0, this is 90, this is 180, this is 270, this is 360, right? So here we have theta, which is greater or equal to 0. Here it's 90 minus theta. It's 180 minus theta because they are less than whatever here, less than 180. 180 plus theta, 270 minus theta. 270 plus theta, 360 minus theta. So here, we said here, your sine theta, your cos theta, and your tan theta are all positive here, right? Here, your sine theta is positive, your tan theta is positive here, your cos theta is positive here, right? Okay, so where our solutions are in a quadrant where this cos is negative. Where is cos negative? Cos is only positive on the first and fourth quadrant. So it's negative on this quadrant here and this quadrant here. And on this quadrant, we have that your x is equal to 180 minus theta. What is your theta? It's 70.53 plus k360, where k is an integer. So you are looking for a general solution, right? Which means it's not just cos. So since this function of ours is periodic, it's constantly repeating. It's repeating itself. So, like I said when I drew it, it will continue repeating itself because this cos x, its period is 360. It will continue repeating itself after 360 units all the time. So now, you want to add that there, that this will be 1 over 3 at this point and after every 360 units or multiples of 360 units. That's what this means. And your second one, this is what? This was the second quadrant, right? So your x is equal to 180 minus 70.59. 180 minus 70.53. So you have 109.47 plus k360, where your k is an integer, which means that this will be called 1 over 3 at this point, and after every multiples of after every added multiples of 360. And then which other quadrant? That is the third quadrant here, where it is negative. So we have x minus is equal to 180 plus our reference angle of 70.53 plus k 360, where your k is an integer. So x is equal to 180 plus 7.53, which is 250.53 plus k 360 units. So which means now your cos x will be equal to negative 1 over 3 at this point, which is at 109.47, and at the multiple plus the addition of the multiple plus the repetitions of the same function, which is at 360 units apart. Similar explanation for this goes as well. So this is how you do this question. So let's move to the next one, 6.4, the last one actually. Okay, so I'm doing 6.4 now. Given x plus 1 over x is equal to 3 cos x, and x squared plus 1 over x squared is equal to 2. Determine the value of cos 2a without using a calculator. So we're given this and that, or this and that. They want us to find the value of cos 2a. Okay, so you need to be familiar with the compound angles in order to do this one. So now, we're given that and this. We want us to find this. So the first thing that we can do is to square that, which is your x plus 1 over x is equal to 3 cos a, right? Square this side, right? So here you can expand this and you'll find x squared plus 2 plus 1 over x squared. If you expand this, is equal to 9 cos squared a, right? So we have x squared plus 1 over x squared plus 2 is equal to 9 cos squared a, right? So this, is equal to 2. So we have 2 plus 2 is equal to 9 cos squared a. So you want cos 2a, and you know that cos 2a is equal to 2 cos squared a minus 1, right? So what you can do here, to achieve this here, we can say, okay, let's multiply here by 2 over 9, and multiply this by 2 over 9. You'll quickly discover that this cancels that. Here left with 2 cos squared a, which is equal to, this is 4 times 2, you have 8 over 9, this side is equal to this, right? So you want to achieve that. So you only subtract 1 and subtract 1. So you have 8 over 9 minus 1 is equal to 2 cos squared a minus 1, which is that now. Which is now we've achieved that. Because you know that this is cos 2a, it's equal to this times that is 8 minus 9 over 9. So your cos 2a is equal to minus 1 over 9. And you're done with this question. You have all the 24 marks. That was nice. Thank you.